Right, welcome back. This is exam prep session 4. We're going to move on from question 11b, okay? So let's have a look. By the way, these are typical exam questions, test questions, that's where they come from, okay? Using Lewis diagrams, show the bonding process of sodium chloride, magnesium fluoride, and ammonium. Okay. Well, what are they asking for us? Lewis diagram are the dots and crosses, right? Okay. So we have to start off, and they've asked us for, I'm on green there, and I always like to start it on black pen. Sodium chloride. So what have we got? We know that we've got a sodium and a chlorine that are bonded together. Okay, so we start off, let's have a look at sodium first. Okay, is Na. Let's have a look. All right, now obviously I've worked them all out prior to this. Okay, let's have a looky here. All right, sodium is number 11. Sodium is number 11. Count it off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's the first one on floor 3, all right? On the third floor, the third basement, if you like. Okay, it's down 3, and it's got 1 electron over, so it's going to be a 3s1, isn't it? So let's have a look. But let's fill it in. So we say it's 1s2, 2s2, 2p6, 3s1, right? So there we go. That is sodium, correct? Now, let's have a look. What are we going to do with sodium? Well, we are going to bond it with chlorine. Well, let's have a look. Chlorine is number what? Okay, Cl. All right, let's have a look. Cl, well, it's in the same grouping, okay? It's in the third floor. Sodium is 11, 12, 13, 14, 15, 16. Chlorine is number 17. Therefore, 17 protons, 17 electrons. Oops, and Kevin goes and puts a 17 electrons. Okay, so what do we say? Let's fill it in. 1s2, 2s2, 2p6, 3s. Now let's have a look. We've got 10 there, and we need to have 17. So it's going to be, not 3s. There's 7 in the whole outer shell. 3s2, okay? 3p, okay, 3p5, okay, because there's 7 in the outer shell, right? Okie dokes. Now, how do we put this together? They say, using this show the bonding process, which means how do they put together? So let's have a look first. Let's put sodium down here, Na, and how many? We put in just the valence electrons, which is 1. And chlorine over here, 1, 2, 3, 4, 5, 6, 7. Okay, so what are we going to happen? Chlorine is a nonmetal. Okay, so it takes electrons, correct? Sodium is a metal. It gives electrons. So sodium is going to give the electron away. It's going to say, there you are. And as we've said before, there's the parking spot. So this electron goes and sits in that parking spot, and we end up with this. We end up with NaCl ... and the sodium sitting in like that. Okay, that's how sodium chloride forms. Next question. Okay, how does the next one was magnesium fluoride. Okay, well, let's have a look. This is, how do we get Mg? How do I write magnesium fluoride? Well, Mg, I know if I look at my periodic table, Mg is a +2, and fluorine is a -1. So this is a +2, F is a -1, so I need 2 fluorines. So that's going to be MgF2. Okay, right, let's have a look. How are they going to bond? Well, first of all, we have to find magnesium, and magnesium is number, well, we know sodium was 11, magnesium is 12. So let's have a look. it means there's 2 electrons. Number 12, 1s2, 2s2, okay, 2p6, 3s2, okay, and fluorine is number 1, 2, 3, 4, 5, 6, 7, 8, 9, so it's 1s2, okay, 2s2, that's 4, 2p5, okay, so what do we do here? Please note this is at the end of the second basement and the others in the third level, right? So what do we do here? We say, right, how do magnesium and fluorine get together? What happens is this. Magnesium, okay, has got 1, 2. So it has got how many parking spots? 1, 2. So that is where the 2 fluorines come in, isn't it? Fluorine, we said was, we've got to put in 7. 2, 3, okay. Yep, you guys are quite right. I should put them in dots. Okay, I tell you what, let's put it in green because it's a toxic gas. Okay, fluorine, 1, 2, 3, 4, 5, 6, 7. Okay, and what happens is there's the parking spot for that one, right? So we can have this electron over here can go and share there, can't it? All right, they're in openings, so that electron shares there. And then what happens in the other side? Well, there's still an opening, which means the other F fluorine comes along and it joins on that side. So we end up with, just going to do it. So we've got an F. I'm just going to put it down here. Okay, go back and do green again. 1, 2, 3, 4. This guy over here, remember, there's a spot there. All right, which means that those electrons can share that. Okay, they share that orbital. Covalent. Co means sharing. Valent electrons, sharing valency. Okay, right. So therefore we've got MgF, okay? So what do we have here? We write it like this. Oops. Oh, no. No, it's not what I want to do is this here. Okay, what do? I say, right, I put my... I'll eventually get this back to, there we go. Mg, and I'm going to put a cross there and a cross there, and then I'm going to put my green, he's going to be in there, and similarly that side, and let's just fill in the fluorine, okay, like so. All right, now here we go. Right, what do we do next? Okay, basically what we've done is we've shown the electric structure and we've shown how that joins to that one, and that's how it forms like that. The only thing essentially is you could say the Mg, okay, and the fluorine, the Mg is +2 and the fluorines are -1 on each side. The next one is the ammonium. Remember, they asked for ammonium. I've done it earlier, just let's recap it. How do we form ammonium? What is ammonium? NH4 plus. It's an ion. So we look up nitrogen, okay? Nitrogen, if you remember from the previous, was it had three structures like that. So we had electrons there and there and there and there. We had a parking space over there, and over there. And what happened was, we know that the 3 hydrogens come along and they share their electrons in there, correct? Okay? I'm just obviously doing this slightly faster. Nitrogen, you'd have to remember which one it was, and it was number 1, 2, 3, 4, 5, 6, 7. All right, it was 7. So it has 5 valence electrons. There they are, 1, 2, 3, 4, 5. It's got a valency of -3. Put it back to black. Valency of nitrogen, -3, hydrogen +1. Therefore, we get 3 of those. But now we've got an extra plus. Where does it come in? Well, what we said earlier is that a hydrogen proton comes along and sits over there like that. Okay? And then this is NH4 plus. And the type of bond that it makes there is called a dative covalent bond. All right? Same as any other bond, covalent, but we just call it a dative covalent. That is how we form ammonia. Okay? Ammonium ion. All right? Right. Now, question 12. Okay? Let's have a look at balancing some of these chemical equations. I haven't picked particularly easy ones. I have also given them to you generally in the form of words. Okay? I focus quite a lot on this because it's quite important getting these names and also the polyatomic ions. And you'll see if you don't know the polyatomic ions and you don't know the basic valencies, very difficult to balance these because from the words, you're not going to be able to get the symbol balanced correctly. Let's have a look. First of all, hydrogen gas, nitrogen gas, and they show states where applicable. I have given the states there, so they want us to say, this is question A. They want us to say, right, question A, hydrogen gas plus nitrogen gas. Hydrogen gas plus nitrogen gas, okay? And they want us to know that forms ammonia gas, NH3 gas, okay? So we've put down the states, okay? They've also asked, is this synthesis or decomposition, and show which are reactants and which are products, all right? Let us immediately start out by saying, guys, reactants are these guys, aren't they? And reactants go to form products, don't they? After all, that's what chemistry is about, isn't it? We're taking stuff, we're mixing it, heating it, cooling it, whipping it, doing all sorts of things, like baking, and then we're making stuff, all right? So it's like, I don't know, mixing cream, ice cream, and whatever else, sugar, and flavorants and colorants and stuff to make ice cream, all right? This is what we're doing here. We've got our reactants. Those are the things that react to make a product, okay? And I've shown that those go to... Now, how do we balance a chemical equation? Always start with your metals or your nonmetals and look at those first, okay? Let's just take this one quite slowly, right? How many nitrogens have I got here? We've got 2, but on this side we've got 1. Therefore, I've got to multiply that by 2 to make that a 2 on either side, right? Right, now my nitrogen, our nonmetal in this case, is balanced. The next step is to say, okay, let us look and say, oh, but hang on this side now, we have got, let's just change the color, we've got 6 hydrogens, 2 times 3. So it means over this side, I've got to put in a 3, okay? So therefore, the final balanced chemical equation is going to be 3 hydrogens plus nitrogen gas goes to 2 NH3 gases like so. What does this mean? Let's just take a moment to recap it. It means that I've got a hydrogen and a hydrogen, another hydrogen and a hydrogen, and another hydrogen and a hydrogen over there. These are both, sorry, let's put them in. Okay, those are my, whoops, he was supposed to be part of this one, wasn't he? Let me just make that a little better, okay? I'm going to rather draw it this way, if you don't mind. H and H, and an H and an H, and over this side, I've got an N and an N. All right, what happens is that essentially this N and N split up, and we get 3 of these guys going with that one, and those 3 go with that one, to give us 2 NH3s. Like that, correct? So each and every single atom is balanced from side to side. All right. Let's look at the next one. Hydrochloric acid. Okay. Oh, is it synthesis or decomposition? Synthesis is making something. Here we are making ammonia. Decomposition is things like rust, or if we take ammonia and we break it up. For example, you could have mercuric oxide. That gets me when it does that. MgO. And you split that up into mercury and oxygen. Okay? 2. I haven't done that one, but there's that. That's a decomposition. Basically, when you break it up into its components. Okay. Now let's have a look. Hydrochloric acid and calcium carbonate. This is B. Hydrochloric acid, HCl. Calcium carbonate. How do we put them together? We know it's a Ca and a carbonate is CO3. Okay? But what do we know? I'm actually going to just move it down a bit. There we go. Hydrogen chloride and calcium carbonate is hydrochloric acid and Ca is +2. Carbonate is -2. Therefore, it is CaCO3. Correct? Okay. Let's just... Okay, CaCO3 like that. And remember the top one, the nitrogen, hydrogen, diatomic gases, right? Because they only exist in pairs together like that. Okay, right. Now, remember this one here this is a standard reaction, isn't it? Which one is it? Hang on, let's think. This here is a what? Hydrochloric acid. Hello? That's telling you it's an acid plus so it's one of the acid reactions. Acid, and this is there it is, a carbonate. Acid plus a carbonate. Now, as we said when we did this section, these are things you just got to know. It's not given to you on any schedule or anything like that at all. You've just got to know them. So what is it? It's an acid and a carbonate, and the net result is we get, or a metal carbonate if you like, we get a metal salt. Which salt do we get? Well, first of all, this is going to break up, isn't it? Into H plus a Cl minus plus a Ca plus 2 plus a CO3 minus 2, right? These things are going to ionize or dissociate in the water, and then we're going to get a mix. This and essentially these are going to get together like that, right? We get this ion exchange. What do we get? We get a metal salt. Metal salt in this case is calcium chloride. But now I've got to be careful. Calcium is a +2. Chloride is a -1. So it's CaCl2. Okay? Remember, this is where the trick comes in. That's why we got to know our periodic table and know the valencies. Yeah, I know. But it's true. Okay? You can see it for yourself. How easy it is to actually do these when you know these things. Okay, metal salt plus what? Hang on, what else did we get? Yes, we got CO2 gas. CO2 gas. And lastly, we got water. H2O. Okay, water's a liquid, isn't it? All right. Now, how do we balance this lot? Well, what do? We first of all, we take it and we say, okay, let's have a look at this. All right. Well, I am going to, no, let's just look at it. First of all, well, let's start off with the metals. Calcium and calcium is balanced, okay? So I can say, all right, I've balanced you and I've balanced you. There's two of you. Chlorine, okay, hold on. Hang on. Well, problem. 2 Cls, remember I'm going with my metals, then my non-metals. 2 Cls here. Oh, only 1 Cl there. So I've got 2 by Cl this side and only 1 that side. So I have to put in a balancing number of 2. Now, okay, let's have a look. Over here, I've now got two H's. Let's have a look. CO2, carbon 1, there's a carbon over there 1. So I can go tick on the carbon, right? Then I've got oxygens. Now let's have a look. 2 oxygens come from there, and on this side we've got 3 oxygens. Okay? 3 oxygens and 2 hydrogens, right? 3 oxygen, and now we've got and 2 H's. There they are. So it's balanced with just the 2 in front there, isn't it? That's quite a nice question because it's testing you on acids and carbonates, and it's testing you on valencies of polyatomic ions. Can you see how they can build up such a lovely question? The next one, okay, that's an acid carbonate one. The next one was potassium. Let me just check it before I give the game away. Let's have a look here. It was potassium hydroxide and phosphoric acid. Well, potassium hydroxide. We know that's a K, potassium, and the hydroxide is an OH. Now we don't know the balancing. As I said before, some students call them baby numbers, these subscripts, right? OH is an hydroxide ion. OH is a -1, and potassium is a +1, so that balances +1, -1. We're done. Okay, that's the individual element there. Okay, or the individual compound, right? Not element, sorry, my bad. Then we say phosphoric acid. Okay, acid's always got an H in front. Phosphoric comes from phosphate, PO4. The PO4 is a -3. Hydrogen's a +1. That you got to know. And hydrogen you could get off the table. You cannot work out the -3 by using P and O4. Okay? Ain't going to work. Okay? So don't go there and say, well, P is in table -3 and 4. Well, let's have a look at it. PO4. P is -3. Oxygen is -2. Oh dear, we've got a problem, right? It doesn't work that way. You have to just learn those, and that becomes thus an H3PO4. What type of reaction is this? Well, it's an acid, and what's anything with an OH? What is this green? It's a base. So this is an acid-base reaction. This is the base plus the acid. And what is that? It's a neutralization, isn't it? What does it give us? It gives us a salt plus water. All right? So let's just roll this down a little bit. And we can go in and put the salt. Well, the salt is potassium phosphate and water. So let's see, potassium phosphate, wow. K and the PO4 get together, right? The K and the PO4 get together, and this are going to get together, okay? And we get H2O, okay? Remember, we know this is going to come out there. So what do we do next? Well, K and PO4, I've got to balance. That's got to be K3PO4. Why? Because PO4 is -3 and K on its own is +1. Therefore, it's K3PO4. Next, what do we say? So, okay, let's look. Okay, K, I need to have, let's put in the balancing numbers in red. I need to have 3 potassiums on that side. Okay, I need to have 3 potassiums on that side. Now my potassium, my K is balanced, right? Now I say, okay, P's balanced there. O4 is balanced. And on this side, I've got 2H and 1O. Well, over here, I've got 3H and 3O. Okay, so what are we going to do there? Okay, we are going to say, okay, 3H, 3O. Okay, we're going to have to put in we've got to balance this guy out now. I see here's in the one I used, 3KOH, H3PO4, K3PO4, and it had a 3H2O. Ooh, okay. Let me just put this back. So we've got here, okay, 3 O's, 3H, all right. But this side we've got H3. So this side we've got 3 H's. Can you see here? From here we've got 3H. Whoops. Sorry, let me just make that. Trying to write right at the bottom. 3H pluses, there's the 3 of them. And on this side, I've got another 3H pluses, right? So what have I got here? I've got 2H. So I've got 6. So our balancing number that we're going to put in is going to be a 3 over there. That gives us 6 H's, 6 H's, 3 O's, and 3 O's come from there. Right? Next one. Okay, next one is slightly different. What's the next one that I put down here? The next one I said is beryllium and fluorine forming beryllium fluoride. Beryllium and fluorine. Beryllium plus fluorine. Fluorine F2, generally speaking, is a gas. Okay? And this forms beryllium fluoride. Right. BEF. How do we work out? Because it's not balanced. You've got to go through the step of saying, I have to balance the small numbers, those little subscripts, the baby numbers. We've got to balance them. So what do? I say, well, fluorine is a -1. Beryllium, okay, is, now let me find it. Take a shortcut, go straight to the answers over here. Beryllium, okay, well, is a solid, that we know. And, okay, beryllium is going to be, there it is, 1, it's number 1, 2, 3, it's number 4, it's a +2. Okay, so how many fluorines do we need? 2. So it's going to be BeF2, correct? Okay, right, now let's balance, okay? BE, F2, F2. Okay, so we've got a balanced chemical equation, which actually means, and let me just stop at this point and say, please remember that in front of each of those is a 1 that's not written. Same as algebra. X plus y, there's 1x and 1y, isn't there? Okay? Always remember that you've got those ones in front over there. Okay, let's have a look at the next guy. Okay. Lead nitrate potassium iodide. Okay, E. Lead nitrate. Well, we know its Pb is lead and nitrate is an NO3. Okay? We'll balance it in a minute. And potassium iodide is a K and an I, all right? And basically they probably will tell you, but if they didn't, okay, the chances are that it's going to react and give you, right? No, you're not going to have Pb and potassium. You're going to have the -1. This is a -1, remember? Let's just put in our numbers on top here. -1, lead, +2, give it to you now. Okay, and the iodine is a -1 and the K is a +1, right? Okay, so what happens generally, the positive ion goes off with the other negative ion, and the other negative ion goes off with the positive one, right? So you get anion-cation pairs in an ion exchange reaction, all right? So let's have a look. I haven't finished balancing. So PbNO3, I actually need to put in a bracket here because there are 2 of those, okay? Remember the ions exist bound together with a charge, okay? It's not N2O6, all right? N2O6 is something completely different, all right? So let's just make sure that we remember the ions are in brackets. I generally put the in brackets no matter what, okay? I mean, I've even put KOH like that in brackets, which is not correct, all right? But I always make sure that I remember my ions go together. So let's have a look at the next bit. What does it go to? Well, let's take a guess without being told. Lead, okay, is the positive one. So this is going to go to Pb +2, and then in the water we're going to have 2NO3 -1s, okay? Plus we're going to have a K plus, and we're going to have an I minus. I said that goes with that, and this one goes with that. So what we've got is we've got lead iodide, okay? Pb and the I go together, right? I'm not sure if I gave that in the original. Okay, let's have a look. Lead iodide and potassium nitrate, I did. So lead iodide, okay, we've got to balance this. Okay, remember the interim step here. Lead is +2, iodine -1. So how many iodines must I have? We have to balance it out to 0. So we've got to have 2 iodines. Plus, we said we're then going to have potassium nitrate, KNO3. NO3 is what? Okay, NO3 -1, K +1. So they go together like that. Okay. Now, how's our balancing numbers going to work here? Let's first of all have a look at lead. Lead, I'll just switch it to blue. Lead, I've got a lead there and a lead there. Okay, potassium, I've got a K there and a K there. All right, so that's all balanced, isn't it? Iodine, next, my other nonmetals, I balance the ions out on their own very often. K is potassium, right? Iodine, I've got 2 there. Okay, so we need to put in a balancing number over here of 2. Okay, now that has changed my potassium. So we go back and put a 2 there. Right, so that's okay. 2 I's, 2 K's. NO3, but I had NO3 2 there. So it is balanced. 2 potassiums, 2 iodines, remember? There's an iodine and another one. And there I've got 2 of them, right? Potassiums, there's 2 K's, and here's 2 K's, right? The NO3 on its own, there's 2 of those, isn't it? And on this side, there's the other portion of the 2. Right, moving along. Let's have a look at number F. Okay, and what did we say on this one? Oh, no, F I've got, sorry, that D. Sorry, my apologies. I missed out E. Sorry, I missed out E. This one over here was actually F. Let's do E. Okay, E was aluminium nitrate hydrogen sulfide. Aluminium nitrate. Now just put down what you know. Aluminium and nitrate. Okay, I've put that bracket around it already. Okay, because I know that it's going to need it, but let's say you didn't. So let's put aluminium and nitrate now. And then it mixes with hydrogen sulfide. Okay, that's going to mix with hydrogen and sulfide, right? We don't know the baby numbers at this stage. Okay, and that's going to go, well, first of all, let's work out the left-hand side. Green. Aluminium, let's go. It's in the 3rd column, 1, 2, 3, right? Okay, so what do we say? It's in there, so it must be a +1, +2, +3. So aluminium +3. What is this? NO3 is -1. So immediately we can say, okie dokie, I can bracket you, and I need to have 3 of these floating with it, right? So there's 3 NO3s attached to my aluminium. Okay, hydrogen plus, let's just keep it in green. Okay, just for completeness. Hydrogen is +1. Hang on, let's look. Hang on, sulfide is in the -1, -2. Just under oxygen, it's 2 back, right? Because remember, 0 is the inert gases. So we go 2 back. Sulfide is -2. So this is going to mean I have to have a balancing number at the bottom of H2S. Okay? H2S is going to then go to, all right, then they tell us that this goes to nitric acid, HNO3 plus aluminium sulfide, ALS. Now we've got to go and balance again, all right? Green, NO3 -1, H +1, right? And over here, Al is +3, sulfide -2. Okay, we've got numbers at the bottom. That's going to be a 2 and a 3, right? Because that is -6 and that is +6. 2 of those, each one -3, +6. 3 of these at -2, so they balance out. Okay, now the last step is to now let's go ahead and balance. Okay, okay. What have we got here? We've got, let's have a look here. All right, over this side now, let's look at aluminium and aluminium there. We've got 2. I'm looking at my metals first, okay? So we need to have a 2 there straight away, okay? Which now means, okay, Let me just check. Then what my next step is, right? Then sulfide, okay? The S3, I've got 3 this side, 1 there, so there's our 3 of them, right? 3 S's. Remember, there's 3 sulfurs attached to each aluminium, right? And what do we get? We need a 3 there, okay? So that gives us, hang on, how many NO3s? 6 of them. 6, there are 6 of these guys, right? 2 times 3, remember? 2 times 3, there are 6 NO3s. So on this side, I need to put in a 6. Then let's balance. I've got here 6 hydrogens, and it's balanced, okay? Metals, non-metals, leave your ion just a bit, and then do the rest, and then take the last is to balance it, right? I've gone way over on this one. What I'm going to do is I'm going to, let's just carry on and make this one slightly too long, all right? And accept my apologies for it, but I'd like to get finished, okay? So let's just do the next one. Is going to be calcium hydroxide plus ammonium chloride. Calcium hydroxide, what do? We start off with what we know. Calcium and a hydroxide ion, okay? And that we said with ammonium chloride. NH, ammonium chloride, okay? That is NH4, isn't it? Because it was ammonium. Remember, ammonia, A becomes before H, right? Think of it like this. Ammonia, okay, and ammonium, if you can't remember. Okay, ammonia, A comes before M, okay? Therefore, 3 becomes before 4. NH3, NH4, okay? Right, we haven't balanced. Ca is a plus 2. OH minus 1, okay? Let's just put in here, put you together, all right? And I'm guessing we're going to have, well, let's see what we get, all right? And they said we get ammonia gas, calcium chloride, and water. Oh, okay, this is quite a tricky one. So let me just roll this down a bit so that I've got space to write. Okay, so what do? Let's first of all balance these guys. What have I got here? Okay, Ca plus there is 2 and OH is minus 1. So we need to have 2 of those. Ammonia is a plus 1. Chlorine minus 1. So that's balanced. Okay. Then they said it went to what? Calcium chloride. Calcium and a chloride is a Cl. Then it says and ammonia, which is NH3 and water. Okay. Just check that that's in fact what I said. Okay. Calcium, ammonium, water did, yeah. Okay. So right now, let's have a look. Calcium is balanced. Okay. Chlorine is balanced. NH3 is balanced. And basically, all right, we've got no, sorry, I haven't balanced my baby numbers on the right-hand side. My bad. Ca is plus 2. That's minus 1. Okay. Ammonia we know is balanced. So therefore, I've got to put in a number over here, CaCl2. So Ca and Ca are balanced. Let's just put in the blue here. Tick, tick. Cl, can you see there and there? There's 2 on the right-hand side. So we need to have 2 on this side. Okay? So now we've got that balanced. Right. Now let's have a look at the rest. Hang on. We've got 2 N's here now. Right? So I've got to put in, I actually am going against my own there and putting these in red. A 2. Okay? I'm now balancing. I need to put in a 2 there, don't I? All right? And basically, last of all is you go and balance your water. Okay? Your oxygens and your hydrogens, right? Hydrogen and then last of all, oxygen. Remember our little thingy of doing it? Last of all, we're saying, right, let's have a look here. And there's my H2O. And what are we going to do? We're going to balance that out. The balancing number is a 2 over there, and there it's balanced. Okay, last one, and once again, my apologies for going over here. Okay, so far, got it. Oh yeah, that was where I did that one. All right. The last one they said is a decomposition reaction. All right, a decomposition of mercury oxide. Well, that means we have to know mercury oxide is going to be Hg and O, right? So let's have a look. Mercury, if you go and have a look at your normal, is +2, -2. So straight away, they are balanced, okay? And that's going to go across to become decomposition, mercury and oxygen, generally as a gas, all right? You don't want to deal with mercury, it's toxic. Okay, now we say, okay, but then I've got to balance this. So let's have a look here. I've got 2 oxygens. Can you see there's 2 there? I need 2 in front. Mercury is 2, and there it's balanced. Okay, right. What I'm going to do is I'm going to have to cut it there because it's getting way too long, and then I'll come back and I'll carry on with the next 3, and we'll go on to question 13. As I say, sorry, there's a lot of them. I'm trying to do them in detail so that we are refreshing and doing the revision. My apologies again for going on for too long. I am sorry about that, but that's unfortunately the way some of them go. Cheers, I'm hoping this is helping. Really, really I am. Bye.